Have you ever wondered what's at the core of our reality? Is it matter, energy, or something entirely unexpected, like lines of code? Now imagine if a machine existed that could peel back the layers of this reality, revealing its secrets. What if I told you that Google's quantum computer, powered by cutting-edge technology like the Willow Chip, might be doing exactly that? Quantum computers operate on principles that challenge everything we know about classical computing. But here's the twist. These machines aren't just about solving faster equations. Some theorists argue they might be tools capable of unraveling the very fabric of existence, a simulated one, no less. Could Google's quantum advancements be revealing the blueprint of the simulation we live in? What if the reason these computers are so groundbreaking is that they were designed, intentionally or not, to reverse engineer the simulation itself? In this video, we'll explore this tantalizing possibility. From how quantum computers operate to why the Willow Chip might hold the key to understanding the simulation, we'll dig deep into the technology, the theory, and the implications for all of us. By the end, you might see our world and the role of quantum computing in a completely different light. And here's the kicker. If Google's quantum computer is probing the edges of the simulation, could it accidentally or deliberately cause glitches in our reality? Stay tuned to find out how the next era of quantum technology might not just shape the future, but rewrite the rules of the present. Let's start with what we know about quantum computing and its connection to simulation theory. Classical computers, the ones we use daily, rely on binary data, zeros and ones, to process information. Quantum computers like Google's Sycamore and its latest advancements using the Willow Chip operate on an entirely different level. They use qubits, which can exist in multiple states simultaneously thanks to quantum superposition. This allows them to solve problems so complex that even the most powerful supercomputers would struggle. But here's where things get interesting. Many of these problems are rooted in understanding systems that resemble the structure of reality itself. Whether it's simulating molecules for drug discovery or unraveling chaotic systems in physics, quantum computers seem to mimic the very building blocks of existence. This has led to a provocative question. Are these machines uniquely suited to decode the simulation we might be living in? The idea of a simulated reality isn't new. Philosopher Nick Bostrom introduced the concept of simulation theory, arguing that an advanced civilization might create hyper-realistic simulations indistinguishable from base reality. Figures like Elon Musk have popularized this notion, suggesting that the odds of our reality being real are astronomically low compared to the likelihood of it being a simulation. Now add quantum computing to the mix, and you've got a tool potentially capable of reverse engineering this hypothetical construct. Google's latest quantum computer, equipped with the Willow Chip, has already demonstrated supremacy in calculations that defy classical systems. But what if the leap from solving equations to probing the structure of reality isn't as far-fetched as we think? As we dive deeper into this topic, we'll explore how this breakthrough could be the first step toward uncovering the ultimate truth about our existence. The main challenge here is twofold: the technical complexity of quantum computing and the philosophical implications of using it to uncover a simulated reality. Let's start with the technology. Quantum computers are notoriously difficult to build and maintain. They require precise conditions like near absolute zero temperatures to function. Even Google's quantum systems, despite their breakthroughs, struggle with issues like error correction and scalability. The Willow Chip, while a marvel, is still a stepping stone in a long journey. But the bigger question is, what happens if these machines actually succeed in decoding the simulation? For one, it raises ethical concerns. If Google's quantum computer is reverse engineering our reality, are we prepared for what it might find? Could it uncover the code governing our existence and in doing so, destabilize the simulation? Some theorists warn that probing too deeply into a simulated reality could trigger catastrophic consequences, like glitches or even a system reset. There's also the problem of interpretation. Even if quantum computers reveal patterns that resemble a simulation's architecture, how would we distinguish these findings from natural phenomena? The overlap between quantum physics and the fabric of reality is already mysterious. Adding the simulation hypothesis to the equation blurs the line even further, making it challenging to discern fact from speculation. Lastly, there's the question of access. Google's quantum computing research is at the forefront of this field, but it's not the only player. Governments, corporations, and even rogue actors are racing to develop quantum technology. If this tech can indeed probe the simulation, who controls it? And how do we ensure it's used responsibly? These challenges make the journey toward uncovering the truth both thrilling and fraught with uncertainty. So, how could Google's quantum computer and the Willow Chip actually interact with the simulation? To answer this, let's break it down. First, consider the nature of quantum mechanics. At its core, quantum theory deals with probabilities, entanglements, and superpositions, concepts that seem almost alien compared to the deterministic nature of classical physics. These phenomena are eerily similar to the behaviors we might expect in a simulated environment. For instance, quantum entanglement, where particles appear connected across vast distances, could be explained as shortcuts or patches in a simulation's programming. Now let's talk about the Willow Chip. This next-generation quantum processor represents a leap in computational power and stability. Its ability to perform operations across multiple qubits simultaneously makes it uniquely suited to tackle problems that mimic the structure of reality. Imagine a scenario where the Willow Chip is tasked with simulating quantum systems on a massive scale. In doing so, it might uncover repeating patterns or anomalies, glitches, if you will, that suggest we're living in a programmed environment. Another intriguing possibility is that quantum computers might interact directly with the simulation's framework. Just as a hacker might manipulate the source code of a video game, a quantum computer could theoretically poke the simulation, causing it to respond. This could explain why some researchers report strange phenomena, like particles behaving unpredictably under quantum observation. As we piece these elements together, the picture becomes clearer. Quantum computers aren't just powerful tools for scientific discovery, they might be the key to unlocking the ultimate secret of our existence. And as we'll see in the next section, the implications of this are both awe-inspiring and deeply unsettling. Here's where it all comes together. The idea that Google's quantum computer, using the Willow Chip, might already be unraveling the simulation. Recent advancements in quantum computing have allowed researchers to solve problems that were previously thought impossible. But what if these breakthroughs are more than just scientific milestones? What if they're milestones in our understanding of the simulation itself? Consider this. The Willow Chip's ability to handle complex calculations could inadvertently uncover patterns in the fabric of reality, patterns that resemble error-correcting codes or programming structures. If this happens, it wouldn't just confirm the simulation theory, it would also challenge the very foundations of science and philosophy. After all, if our reality is programmable, then our understanding of physics, chemistry, and biology becomes a study of the rules set by our programmers. But the most chilling possibility is what happens next. If the simulation's creators realize we're onto them, would they intervene? Could our discovery of the simulation trigger changes, glitches, resets, or worse? Some theorists suggest that our growing mastery of quantum computing might already be drawing attention from the watchers within the simulation. At this pivotal moment, we're left with more questions than answers. But one thing is clear, Google's quantum computer isn't just advancing technology, it's probing the boundaries of reality itself. And as we venture deeper into this uncharted territory, we must prepare for the profound implications of what we might find. To recap, we've explored the groundbreaking potential of Google's quantum computer and the Willow Chip in the context of simulation theory. From the basics of quantum mechanics to the possibility of reverse engineering our reality, it's clear that this technology is more than just a scientific tool. It's a window into the very nature of existence. We've examined how quantum computers could reveal the structure of a simulated reality, uncovering patterns and anomalies that point to its underlying code. We've also discussed the ethical and philosophical challenges this poses, from the risk of destabilizing the simulation to the responsibility of wielding such powerful technology. At the heart of it all lies a profound question. Are we prepared for the answers quantum computing might provide? Whether or not we're living in a simulation, the advancements we're witnessing represent a turning point in human understanding. And as we move forward, we must navigate this new frontier with curiosity, caution, and a willingness to embrace the unknown. What do you think? Could Google's quantum computer and the Willow Chip be unraveling our simulated reality? Share your thoughts in the comments. We'd love to hear from you. If you enjoyed this dive into quantum computing and simulation theory, like, subscribe, and hit the notification bell for more mind-bending content. Stay curious. Thank you for watching.